Hello, this video is to help people learn to use the BioPack BSL Analysis software. Now, first of all, let me quickly explain the difference between this and the BioPack Student Lab software. BioPack Student Lab is the full software that lets you run the BioPack machine and analyze data. It costs money and is installed on the lab computers at Palomar. The BSL Analysis software is available to download for free from the BioPack website. There's a link in the syllabus, and maybe I can put one in this video. But all it can do is analyze existing data. It can't run the BioPack software, which is perfect for this online sort of lab session, because it means that you can have the software and do the same kind of data analysis you would do in the lab, which is part of what you're learning to do in a science course like this. So what I'm going to show you today is how to use that. So here on my laptop, I have installed I've actually installed both, but down here is the BSL Analysis 4.1 software. That's the one you want. Now, you have exactly the same icon for the BioPack BSL 4.1. What you want is BSL Analysis, which should be the only one you have. So when you start it up, you should get a screen that looks like this. And there are a lot of options here we won't use. For example, you can look at a video for a tutorial on how to use it, which, might not be a bad idea for you. You can run through a lesson prep. If we were doing in-person labs, that might be useful, but since we're not, what we're going to do is analyze our own data. So when I click on that, it's going to ask me where to get that. We are going to open a lesson data file for analysis. Now, you should have downloaded the sample data for this lab 7A, from the website. But if you haven't, we'll just make sure you have a set of sample data to use. So I'll do that, and I will find my file. 7A, there it is. Now, I'm glad I did this, because here's the data file I want, but it's grayed out. And that's because right now, this software is looking for lesson files. The BioPack software records files in two different formats: acquisition, also known as BSL Pro, or lesson files. I have saved this data in the Pro format, so we're going to need to make sure it knows we're looking for Pro files, which are .acqs. And now it says, oh, so you want that one. We say, yes. Click Open. Now, up pops the saved data from that analysis. This is actually sample data that I got from one of the other labs that you will actually be looking at later in this course. So, there are several things on here, and one of them that we don't need is this automatically created lab journal. I don't think I've ever used that in this course. So what I'm going to do, just to make this a little easier to see, is move my cursor here where it turns into the little up and down arrow, and just click and drag that to minimize that journal so we don't have to look at that. All right, now let's walk through what you're seeing here. So in the BioPack software, in this particular one, we have two channels. You can see one channel up here. Oops, that's not what I wanted. And one channel down here. So by clicking on each channel, I can highlight one channel or the other. And 4 acquisitions. So each acquisition is set off by this thick black bar. So this is the first acquisition, second acquisition, third acquisition, and fourth acquisition. Now, each channel is a different either recording from a sensor or a calculation, or sometimes even sort of both. So in this particular one, and there's no way for you to know this just by looking at this, but I'll tell you what these are. This is the integrated EMG data from my forearm as I was gripping a sensor, and this is the amount of force that was generated from the sensor while I was gripping it. So we had 4 acquisitions. In this first one, we gripped 4 times with gradually increasing force. In this one, we gripped hard and then tried to maintain a grip, and what you're seeing is fatigue. In this one, we were doing the same thing about gripping with increasing force, but we were using a different hand, and this was another fatigue experiment with that same hand. All right, now, some other things you'll need to know when you're looking at data with this. Down here on the bottom part, the horizontal axis, is going to be time. Now, this is actually showing time not just for each acquisition, but over the entire thing. So the fact that the time is continuous here from 32 to 40 seconds doesn't mean that this acquisition went straight from here to here. It's just saying the time in the whole file measured in seconds here. Each of these could have been acquired any amount of time apart. Over here on the vertical axis, we have a different axis for each channel. This is what's being measured. So it may be a little hard for you to see, but this top one, which is measuring the integrated EMG, the units shown here are microvolt seconds, which probably doesn't mean much to you right now and isn't really all that important for us. Down here, the unit is kilograms. So that was actually the sensor is set up to give me the amount of kilograms of force that I am exerting in my grip. So then we have, of course, the numbers here showing how many kilograms and how many microvolt seconds. Now, probably one of the most important things you're going to be doing when you're looking at this data is trying to change how this looks. You might want to zoom in on a part or zoom back out. And there's a couple of tricks to doing that. So let me show you several different aspects of how you can do this. First of all, I should also notice up here, there are 4 different cursors you can use. This arrow cursor is used for selecting waveforms and changing menus and such. This cursor, the I-beam cursor, is used to select periods of time within the recording. So there I'm clicking and dragging. This, the magnifying glass cursor, is used to zoom in or to zoom out. And this, the text annotation cursor, is used to put in notes of your own. So, what a goober to grip like this. Yes, there we are. And very useful, of course. All right, now, let's talk now for a moment about how to change what this looks like. So, first, let's look down here at the time axis. If I wanted to zoom in on a particular period of time, like for example, if I wanted to display what it was between 82 and 114 seconds, if I use my arrow cursor and click on one of these numbers, it can say, okay, well, what time period do you want to display? So if I said, show me from 82 seconds to 114 seconds, and click OK, now it's showing me just that particular time period. Now, I may want to go back to what I was looking at before. The easiest way to do that is probably to right-click anywhere in here and say Show All Data. And it takes me back to the overall view. So I can set the time to look like any particular period I want by clicking on one of these numbers. Now, if I want to change the vertical scale, like say I only want it to show me what's between 0 microvolt seconds and 0.5 microvolt seconds, I could do something similar. Click on one of these numbers. Upper should be 0.5 micro, and down here should be 0. Now here I can also apply to all channels, but that would be a bad idea here given that these are in completely different units. So if I do that, it's changed the scale here. And of course that doesn't work very well for some of these other parts. So I might want to do what I did before and say Show All Data. Show All Data takes you out to basically as zoomed out as you can, and with the vertical scale set to show all of the data with a comfortable margin on either side. Now, I might also want to do this in a slightly more intuitive way by zooming in on a particular part. I might say, I want to get a closer look at what's going on here. So I can click on my magnifying glass and zoom in on a particular area. Notice it's zooming both channels. It's changing the time scale on both channels when I do that. It has no easy way of showing a different time scale on one channel or the other. So that lets me get a good look at this. Now, if I want to zoom back out, on my Mac, what I do is hold down the Option key and click. And it zooms me back out. I believe it's the same on Windows, but it'll be one of those keys down in the lower left of the keyboard. You can probably figure out which one if you're using a Windows machine. Now, probably the most difficult thing you might want to do is to say zoom in on a particular to say I want to zoom in on this. Let's zoom in there, and then say, but I want the vertical scale to show me everything just at this time scale. One very useful thing you can do in here is to right-click and say Auto Scale. So if I told it auto scale single waveform, what it's going to do is change the y-axis on this one to make it so that I can see all the data. It's similar to the show all data, except only doing for the vertical axis. I could also right-click and say auto scale waveforms, in which case it would do it to all the channels at once. So that can be a really useful thing. If I now zoom out, oh, now this scale is completely wrong, so we can auto scale waveforms and just kind of put things back to a reasonable level. Now notice, all of what I just did only changes what the data looks like. It doesn't actually change any of the measurements, and it wouldn't have any effect on my ability to take measurements like I'm about to show you how to do. But it is useful for letting you select a particular period or get a look at what something looks like. So that's handy for that. Having all of these analysis channels would more often be useful if I had lots of different channels of data at one time, but there are still some ways that they can be useful even when I've just got a couple of channels like this. So let's take a look at what these channels can do. For each channel, for each analysis channel, I can say what channel to record from, like we just saw, and I can say what to calculate. And there's a few of these values that would be the most common ones that we would use. So let's take a look at what these are. Value, if I have it show me the value, then it's just going to show me whatever is at the area that I'm currently clicking. So for example, down here, this one is currently set to give me the value on channel 41, which is this clench force, from whatever location where I have clicked. So I click here and say I was getting a value of 30.37-ish kilograms, whereas that is 41.25 kilograms, and so on. So value is just wherever you click. Now, that doesn't really work, notice, with this cursor. For most of these analyses, I have to be using the I-beam cursor. So another thing that I can get is delta, which is the difference between whatever the value is at the beginning of the selected period and the end. So if I wanted to know how much did my force decrease over the course of this, I might start with my maximum and go to my minimum over here. Notice as I pull this across, it starts at 0 and there's no difference. And then it shows increasing negative numbers there under delta because the force is dropping off. So it's saying at this point you are 18.55 kilograms less than where you started. That's the negative. If I clicked and went back this way, it's saying from where you started to where you're dragged to, you're now 18 kilograms greater, and so on. So you get the idea. Delta is just the difference in value. If I used P to P, that's the difference between the highest and lowest point in the selected region. So here's something interesting about that. Let's say I start here at the very beginning and go to the very end, and I get 42.34 kilograms. If I start at the very top and go to here, I get a very similar number because the difference between highest point, which is almost where I started, and lowest point is about the same. In fact, if I start back here a little, I'll bet I'll get almost 42. So P to P is the difference between the high and low point in the selected region. So if I wanted to really observe the difference between the high and the low point, this would work kind of similarly to delta. I still have to stop where I think the clench stopped, but it's still showing me a difference of about 18 kilograms. There are other times when delta is exactly what you want. When you want to know between two periods what was the total drop from high point to low point. So that's P to P. Kind of similarly, our max and min. Max will show me the highest point in the selected region. Notice if I start here and start dragging, it's getting higher and higher, and then once I pass the actual high point, it doesn't get any higher because the high point is where it is, and selecting all this doesn't change that. Minimum is similar in that as I drag over here, it's finding lower and lower new points as you go. So it tells you the minimum in the selected area. Another common one you might use would be mean, which will show you the average of an area. That might not be so useful in this fatigue one, but if I wanted to know the average force during the time I was clenching here, it would make a lot of sense to select something like that. And that would show me the average during this period. And finally, delta t, skipping down here, is the difference in time in the selected region. So if, for example, I wanted to know how long I held this particular grip here, I could say, well, let's say it started at the top and went to here is where I let it go, and that's 2.39 seconds approximately. So those are some of the common measurement techniques you'd use. So for all of those, remember, what you're going to do is make sure that you've set up at least one channel to show you what you want. Use the selection cursor and then select the region where you're measuring from. Now, having multiple channels here could be kind of interesting in that, let's say, for example, I wanted to know how much this dropped off in the EMG compared to how much this dropped off in force. So I could set this one to be P to P on channel 40, which is this channel, and this one to be P to P on channel 41. So now if I select a particular period, it will tell me that during the selected period, the difference between maximum and minimum in my force was 17.5 kilograms. And the difference from maximum to minimum in my EMG was 0.604 millivolt seconds. That might not actually be very useful for me to know, but the reason that it can be useful to have these multiple channels is because you might want to know several things at once. I could even add in, say, also show me how much time is included in that. So this is saying in the 38.94 whatever seconds that is selected on these two channels, these are the values you saw. By using those intelligently, you can sometimes be very efficient in your ability to measure things. Usually in the lab, your instructor will have some suggestions or direct instructions on how to measure these things, but it's possible that you might have to figure it out yourself. And so here's what I'm going to suggest you do if you want to practice this. You have access to this sample data file. So there are two things I would like you to try to measure. Number one, determine how long the subject held the contraction in the second acquisition. Number two, determine the average force produced during the first squeeze of the first acquisition. So I'll put the numbers that I get somewhere where we can find them. But you should try doing it and seeing if you get numbers similar to what I get. And then you can know if you're approaching this in a similar way. Now, you probably won't get exactly the same numbers because it'll depend a little bit on exactly what region you select, but they should be close. All right, give that a try, and I'll put up the numbers I get here at the end of this video. So pause this, or stop it, try it out, and then come back and check what numbers you get and see if they match. All right, good luck.